All right, here's your last lesson, order of operations with rational numbers. Let's go ahead and take a look at your learning goals. You have learning goal number 16. I will be able to evaluate order of expressions involving rational numbers. So since that's learning goal 16, let's go ahead and put your date up here in your table of contents and record down learning goal number 16. All right, in the page sorter, let's head all the way back down and take a look at these problems. Now, you know that this is something you have to really slow down and focus on because it's easy to make silly mistakes even if you do understand what you're doing. So we're going to follow, please excuse my dear Aunt Sally, order of operations. And remember, you're never going to need to subtract integers if you're using KFC. And so similarly, if you see division of fractions, you'll never need to do that either because of multiplying by the reciprocal. All right, let's go ahead and look at 1, 2, and 3. It's really a review and focus on the expression or the exponents. So let's take a look at this and just, we know there's some things we need to remember. First is pay attention to what the base is. If that negative is not in parentheses, then it is not included. So really this is, what we're doing is 2 to the second power. This negative actually means opposite, or it's like -1 times that expression, okay? And so what we'll do is always use this trick of pulling it out and writing what it is so we can solve it. And then we can see that we're going to take the opposite of that and bring in the negative. So we end up with -4/5 as our answer. Let's go ahead and highlight our answer and move on. All right, the next one, the first thing I notice is that this entire fraction is actually in parentheses, not just this 2. And so I'm going to go ahead and rewrite this as -2/5 times -2/5. And I like to go ahead and make sure, put the negatives up in the numerator. It's just easier to do the math work. And so then we see negative times a negative is a positive. So hate to hate, you actually love. And then 5 times 5 is 25. And there's our answer for that one. All right, now over here, according to, please excuse my dear Aunt Sally, there's no punctuation that actually needs solved. It's just an organizational punctuation. So we're going to take care of this exponent. If I pull this out, I see it's -5 times -5. Hate to hate, so we actually love. And I go ahead and now I can rewrite this as a -2 25ths, okay, as my answer. All right, let's go ahead and look at these. We're going to get a little bit more complicated as we go. First thing I want you to notice is, and this should be a little bit bigger even, the fraction bar is actually this, okay? And so this is 5/3 divided by 7. Never look at it and solve it like that. Instantly just rewrite it as 5/3 divided by 7/1. Anytime you see division of fractions, it's something that you're never going to have to deal with because we can multiply by the reciprocal. I know in other grades they've talked to you about the phrase like keep, switch, flip, but as you get into Algebra 1 and Algebra 2, you want to be using the language multiply by the reciprocal. And so now we can multiply straight across and we end up with 5/21, and that's our answer, okay? All right, and then on to number 5. I see an addition problem of fractions. And so when we're adding fractions, we just need to make sure that the denominators are the same, and they are. So we have a 6/4 divided by 4/1. So I'm just taking that up and representing it as 4/1 instead, since we're working with fractions. We never want to divide by fractions, so we're going to multiply by the reciprocal. When you're multiplying fractions, you want to see if you can cross simplify first. So I can see 6 and 4 are both even numbers, so I know I can divide by 2 out of each of those. So if I divide by 2, I get 3. If I divide by 2 here, I get 2. Okay, so we simplified those. So we have 3/4 times 1/2. Multiply straight across, and we get 3/8 as our final answer. And cross-simplifying just helps make the problem smaller and easier to manage. Okay, all right. Now we can go ahead and look at these even more complicated expressions. So we know that for these, first thing I'm going to do, because I would want to get these correct if I'm taking a test, is I'm going to rewrite Pemdas real quick just so I can think about this. I like to make the MD and the AS stand out differently because those ones we do in order from left to right, whichever comes first. Please remember that a lot of the subtraction ones you won't even be doing. Sorry, my pen keeps changing to eraser. Because of multiplying by the reciprocal with division, or with the subtraction, we're going to do KFC, that kind of thing. Okay, so let's go ahead and take a look at each of these problems. So number 6, I'll zoom into this. According to order of operations, we look and see if there's any punctuation. There isn't any punctuation that needs done, just organizational punctuation. So we're on to the exponents. When we have 2 large numerator and denominator expressions, remember that sort of you have this imaginary math of punctuation up here that says you need to take care of the entire numerator first before you even do the division of the denominator. And so we're going to just sort of pull this out separately and take care of our numerator work. And go through with that. So I'm just going to do a quick rewrite, or maybe I'll even take this, copy, and well, let me paste. Yeah, there we go. That'll be nice. All right, so I'm going to shrink this up a little bit so I can write a little bit smaller, and we'll go ahead and take care of the numerator. So right here, I'm going to do my trick of pulling this out. I know it's a -4 times a -4 times a -4. And so we have, I hate to hate, so I actually love. And then 16 times -4, love to hate, is a -64. So I'm going to go ahead and write that down and then bring down the rest of my work. Now I'm going to keep the parentheses because it's representing multiplication. And so it's really important to keep that organization there. All right, now I'm looking to see if I have any multiplication or division. And I do see right here, I'm going to use this trick of underlining my next expression that I'm going to solve. So I have a 3 times a -64. And notice I'm not including the minus symbol in front of the 3. So I'm just doing 3 times 64. For any of these problems, you can actually use a calculator to help with the problem, but you do need to show the steps of work that's happening. Okay, so I have a 3 times a 64, and then I'm going to make it negative. And we have a -192. Now, again, pay attention to what we used. All we did was this here. So I still need to bring down this 2 minus and the -10. Okay, we're done with multiplication. Now we just have all this subtraction. So we don't like doing subtraction. It makes us feel bad, so we head to KFC. So I'm going to keep the 2, flip, and change, and end up with a 2 plus 192. We're going to work from left to right. So I know 192 plus 2, I don't need to do that on a calculator, is 194 minus 10, and we end up with 184 as our final answer that I'm going to highlight. Okay. However, that's just the numerator, so we don't want to stop there. Okay. So now, so maybe I shouldn't highlight that actually. I'll just maybe circle it. Now I'm going to go ahead and take care of our denominator. So let's do the same thing. I'll pull the denominator out here, paste image, make it a little teenier. And I am going to label now that I'm doing the denominator. All right, so let's go ahead and solve this. According to, please excuse my dear Aunt Sally, order of operations, we'll take care of this exponent first. I'm going to pull this out and show that's a -4 times a -4 times a -4 because the -4 is in parentheses. Oh, actually, I almost got tricked on that. If you look really carefully here, the parentheses, it's not like this with the 3 outside. The parentheses are on the outside of the 3. So this is actually the base of this is right here, and this is just meaning opposite. So you can see how really careful you have to be with these kind of things. So this is 4 times 4 times 4. So we have 16, and then times 4 is 64. And then the opposite of that is negative. So it ends up being negative anyway, but that could have been a big mistake if it was like to the second power. We would have got a different answer. So let's go ahead and rewrite this. We have 2 minus 3. I'm going to go ahead and keep the parentheses to show the multiplication. Okay, and now I need to identify what operations I still have left. So you have to ask, do I have any multiplication or division? And I do. I'm going to go ahead and underline that right there. So I have a 3 times a -64. So I'll do 3 times 64 negative. And we get -192. Focus on what you used and what you didn't use. Okay, so I still have 2 minus. I'm going to do keep, flip, change. And I end up with 194 for my denominator. So now I look at my two numbers, and I have a 184 divided by a 194 as my final answer. Let's go ahead and just see what decimal that creates. Divided by 194, and we end up with this giant number there, and it doesn't look, let's go ahead and read it, 948453608. It's not repeating at all. So we're going to go ahead and we can highlight this. Now I could simplify it at least. I know that those are even. So we could do 184 divided by 2 over 2. And we end up with 92 over, let's see, 97. And I'm not sure, we're going to leave it right there at that. 92 divided by 97 is our final answer. Okay. All right, let's go ahead and take a look at number 7. So we have a lot of different punctuation. So we're always going to look at our inner punctuation first. I see that my most inner punctuation is right here. And we have 8/5 plus a -2. Let's see if 8/5 and 12/5 can turn into a decimal. If they can, they might be a little easier to work with. So let's go ahead and take a look. So 8 divided by 5 actually is 1.6. So I'm going to do a little bit of rewrite here. Plus a -2 in brackets squared. And then let's see what 12/5 is. Is actually 2.4. So since these changed to decimals, we can go ahead and do this. If they were repeating or just never ending, then we need to keep them as fractions. But in this case, we don't need to. All right, so let's go ahead and do our innermost parenthesis first, which is 1.6 plus a -2. It's our addition song, so different signs subtract. So we're going to do 2 minus 1.6, and we get 0.4. But we keep the sign of the bigger digit, so it's a negative. So at this point now, when I do my rewrite, I still have all this. And here we go. Okay, so our inner parenthesis is done, but now we have the brackets. So we're still dealing with punctuation first. So I have a 2.4 divided by a -0.4. So that parenthesis is just organizational. We can go ahead and do this when we're doing division of decimals. We can just go ahead and do our love-hate. So that's 2.4 divided by 0.4 negative, and we get -6. Okay, and then all of that is to the power of 2. If I pull this aside, I can see my base is the entire -6 times the -6, which gives me a positive 36 as a final answer. Okay, all right, and last one over here. Let's go ahead and look at this. All right, so we have a whole bunch of stuff going on. So if we're thinking, please excuse my dear Aunt Sally, we're looking at parentheses first. So I have parentheses here I can take care of, and I also have parentheses here to take care of. And you can take care of those at the same time if you want. So I have division of decimals in both of these situations, and so that's just a love-hate situation. So let's go ahead and pull the calculator back out. We have a 3.9, and you can type it exactly as is and just write the answer, or you can do your love-hate in your head. It's up to you. Divided by 0.6, and so it's 6.5. If I hate to love, I actually hate. So I know this is a negative. I better do it a little lower. Negative 6.5. And if I typed it in accurately, it would have said that anyway. You can see 3.9 negative divided by 0.6 equals negative. What did I do wrong? Oh, I forgot my decimal point there. That's why it shows wrong. So I'll always be checking reasonableness. All right, and then we have this, and we have times this bracket of 1 plus, and we can go ahead and take care of that parenthesis as well. So we have 8.1. I already know the answer is going to be positive because it's a negative divided by negative, but I'll go ahead and do it as is. So negative 8.1 divided by 2.7 negative, and it equals 3. So there's that. Okay. And now we can do the 3 plus 1 is 4 times the negative 6.5. I don't need the organization of those parentheses anymore. Now I have a multiplication of decimals and whole numbers. So it's a hate to love. So I know I'm going to hate at the end. So I have a 6.5 negative times 4 equals negative 26. And there we go with our final answer. All right, so that is dealing with order of operations with rational numbers.